Welcome to Cambridge IGCSE Physics, Lesson 57.1, Effects of Ionizing Radiation. Today we explore how ionizing radiation affects living organisms, including cell damage, mutations, and cancer development. This core content lesson provides essential knowledge for understanding radiation safety and biological impacts. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, state effects of ionizing radiation on living things, including immediate and long-term impacts. Second, describe cell death mechanisms and their consequences for organisms. Third, explain mutations and cancer development processes caused by radiation exposure. These objectives align with Assessment Objective 1, focusing on scientific knowledge and understanding of biological effects. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, ionizing radiation means high-energy radiation that causes ionization in matter by removing electrons from atoms. Second, cell death refers to the destruction of cellular structure and function when radiation damages vital components. Third, mutations are changes in genetic material, specifically DNA structure, caused by radiation damage. Fourth, cancer is uncontrolled cell division resulting from damaged DNA that can no longer regulate growth properly. Understanding these terms precisely is crucial for exam success. Let's explore our first core concept, biological effects of ionizing radiation. The fundamental principle states that ionizing radiation damages living tissue by breaking chemical bonds within cells. This occurs because high-energy particles or electromagnetic waves remove electrons from atoms, disrupting molecular structure. The mechanism involves three primary effects. First, direct damage to DNA molecules which contain genetic information. Second, disruption of cellular processes essential for life. Third, formation of harmful free radicals that cause additional damage. The diagram illustrates how radiation penetrates a normal cell and breaks DNA strands. Notice the orange arrows representing incoming radiation and the red dashed line showing where the DNA breaks. This damage is the foundation of all biological effects we'll study. Now we examine cell death mechanisms. This follows a predictable process where radiation causes either immediate or delayed cell death. Immediate effects occur with high radiation doses. These destroy cell membranes instantly, causing cellular machinery to stop functioning and rapid tissue damage to occur. The cell cannot maintain its structure or carry out life processes. Delayed effects happen with lower doses over time. DNA damage prevents normal cell division, so cells die during attempted reproduction when they cannot replicate properly. The diagram shows this progression. A healthy green cell receives radiation exposure, becomes damaged with broken internal structures shown in red, and finally dies, represented by the black circle. This sequence explains why radiation sickness symptoms may appear hours or days after exposure. Let's work through our first example. The problem states, a patient receives 2.5 gray radiation dose during medical treatment. Describe the likely biological effects. We are given a radiation dose of 2.5 gray, where gray is the SY unit measuring absorbed radiation dose per kilogram of tissue. We need to find the biological effects at this dose level. Step 1. Identify the dose level. 2.5 gray represents moderate radiation exposure, higher than background but within medical treatment ranges. Step 2. Immediate effects. The patient may experience nausea and fatigue within hours as cells begin responding to damage. Step 3. Cellular effects. Some cell death will occur, particularly in rapidly dividing tissues like blood cells and intestinal lining. Step 4. Long-term risks. There is a slightly increased cancer risk over the patient's lifetime due to DNA damage that may not be perfectly repaired. Example 2 examines mutations and genetic damage. The process involves radiation damaging DNA structure, causing genetic changes that may persist. There are 4 main types of damage. First, single-strand breaks where one side of the DNA double helix is severed. These are often repairable. Second, double-strand breaks where both sides break, which are more serious and harder to repair correctly. Third, chemical changes to DNA bases, the letters of the genetic code. Fourth, chromosomal rearrangements, where large sections of genetic material are moved or lost. The consequences are significant because mutations may be inherited by offspring if they occur in reproductive cells. The graph shows how mutation rate increases with radiation dose. At 0 dose, there's a baseline 1% mutation rate from natural causes. This rises to 24% at 5 Gray, demonstrating the linear relationship between dose and genetic damage. Cancer development represents the most serious long-term effect of radiation exposure. The mechanism involves radiation-induced DNA damage, leading to uncontrolled cell growth when repair systems fail. The process occurs in 3 stages. First, initiation, where radiation damages genes that normally control cell division, particularly tumor suppressor genes. Second, promotion, where damaged cells begin dividing abnormally, ignoring normal growth signals. Third, progression, where cancer cells spread throughout the body and form tumors in multiple locations. Several risk factors influence cancer development. Higher radiation doses increase cancer probability in a roughly linear relationship. Younger age at exposure increases lifetime risk because there are more years for cancer to develop and young tissues are more sensitive. Some tissues are particularly vulnerable, including thyroid gland and bone marrow. The latency period is crucial to understand. Cancer may develop years or decades after initial exposure, making the connection difficult to establish. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, state 3 effects of ionizing radiation on living cells. Think about the different ways radiation damages cellular components and functions. Question 2 is intermediate level. It states, explain why cancer may develop years after radiation exposure. This requires you to apply concepts about DNA damage, repair mechanisms, and the multi-stage cancer development process. Question 3 is advanced level. The question is, compare immediate and long-term effects of high-dose radiation exposure. This tests your analytical skills in distinguishing between acute and chronic radiation effects. For all questions, remember to use scientific terminology correctly, explain the underlying mechanisms, and give specific examples where appropriate. Write your answers now, before looking at the solutions. Physics principles about radiation effects power critical real-world applications. In medicine, radiation therapy uses our understanding of how radiation kills cells to target cancer while minimizing damage to healthy tissue through precise dose calculations and targeting. In safety, radiation protection standards limit exposure for nuclear workers and the general public based on biological effects research, preventing harmful doses. In research, understanding radiation effects guides space exploration missions, where astronauts face cosmic radiation, and nuclear technology development, where worker safety is paramount. Career-wise, this knowledge leads to medical physics, where specialists calculate safe radiation doses for patients, radiation protection, where experts monitor and limit exposures, and nuclear engineering, where safety systems prevent harmful releases. The global impact is enormous. This knowledge protects millions of people worldwide from radiation hazards in medical procedures, nuclear facilities, and natural exposures. Let's review the solutions. For question 1, the answer includes 3 main effects: cell death from membrane and organelle damage, DNA mutations from broken chemical bonds, and cancer development from uncontrolled cell growth. For question 2, cancer develops years later because DNA damage accumulates over time, cancer requires multiple genetic changes to develop, and there's a latency period allowing progression through initiation, promotion, and progression stages. For question 3, immediate effects include cell death, tissue damage, and radiation sickness symptoms, while long-term effects include cancer development, genetic mutations, and hereditary effects passed to offspring. Now for exam success tips. First, use command words correctly. State means list facts without explanation, while explain means give reasons and mechanisms. Second, include mechanisms in your answers describing how radiation damages DNA and cells at the molecular level. Third, give specific examples such as which tissues are most affected and typical dose levels. Fourth, link concepts by connecting cell damage to cancer development processes. Let's summarize today's lesson on effects of ionizing radiation. The key points to remember are, first, cell damage occurs because radiation breaks chemical bonds in vital molecules, causing either immediate cell death from membrane destruction or cellular dysfunction from damaged organelles and DNA. Second, mutations result from DNA damage that creates genetic changes, which may be inherited by offspring if they occur in reproductive cells. Third, cancer develops through a multi-stage process starting with DNA damage to growth control genes, progressing through abnormal cell division to tumor formation and spread. These three concepts form the foundation for understanding radiation biology and safety. For further study, review how biological effects vary with different radiation dose levels, practice explaining radiation protection principles based on biological effects, and prepare for the next lesson on radiation detection methods, which builds on today's work by exploring how we measure and monitor radiation exposure. Ensure you understand today's biological mechanisms before moving forward, as radiation physics builds systematically from basic effects to practical applications.